When you were a kid playing with friends, did you ever wonder which shape could be thrown the farthest? For example, a cone, a sphere, a cube, and a cylindrical surface. They all have the same mass and material, just different shapes. Which one do you think can be thrown the farthest? Some might say the cone, because its sharp tip can cut through the air, and it has the smallest surface area, reducing air friction. Others might say the sphere, because it's the smoothest and most aerodynamic, so it can be thrown farther. But the reality might not be what you expect. Historically, there have been similar questions like the development of bullets. The earliest bullets were spherical. Later, in 1718, Parker invented the square bullet, and in 1830, Delvine invented the conical bullet. By 1898, the French army adopted pointed bullets for the first time. When we compare different bullets, we find that the ones that travel the farthest have the most streamlined and elongated shapes. Why is that? Let's take a look at what happens when air flows over an object's surface. When air flows over a smooth surface, it sticks closely to it. The friction between the air molecules closest to the surface and the object is high, causing them to move slowly. Higher layers of air face less resistance and move faster, forming what is known as the boundary layer. Above this layer, the airflow remains at its original speed, creating a smooth, orderly movement called laminar flow. However, if the object's shape changes suddenly, the airflow becomes turbulent. When the friction between the air and the object's surface suddenly vanishes, the boundary layer is disrupted, causing changes in the airflow's speed and direction, leading to turbulence. In turbulent areas, air pressure drops, pulling the object towards the turbulence, a phenomenon known as pressure drag. For instance, the small bumps on airplane wings generate turbulence, creating pressure drag that lifts the wings and makes flying easier. So, whether an object can be thrown farther depends not only on its friction with the air but also on pressure drag. The smaller the curvature of the object's edges, the less likely it is to generate pressure drag. Therefore, with similar frontal areas, objects with smaller curvature can be thrown farther. Among the shapes mentioned, the cylindrical surface can be thrown the farthest, followed by the sphere, the cone, and the cube.